All right, one is August the 7th. All right, so we have to figure out what's wrong with this one and then do today's new one. And because it's a medium question, so we're gonna go back to Java. Yeah, I pretty have to delete this whole thing and then do the new one, but it's okay. Old problem. There is a integer array, nums sorted in ascending order. Prior to being passed to a function, nums is possibly rotated at an unknown pivot, such that the resulting array is k plus 1, and then, okay. Given the array nums after the possible rotation, return the index of the target. Yeah, just binary search, but we'll have to figure out what type of binary search do we do. So we have 4, 5, 6, 7, 0, 1, 2, right? 4, 5, 6, 7, 0, 1, 2. So you give me a target, okay? And then I go low, high. Now we pick a middle, right? And then we are going to compare to the target, right? Compare to the target, and we say if the value is smaller than target. Now I think I have to go a few, so we have to know this and this. These two we know, right? So if your value is smaller than this value, right, then it must be in this half, because this is bigger. If it's bigger than this, it must be in this half, right? Therefore, you have a middle point, so the middle point can be on this half, or the middle point can be on this half. And then we'll compare the value, the target, with yeah, because there's only a few possibilities, right? If the value is in between these two, then it must be in this half. Then we're done. If the value is in between these two, right, because what we say is we find the middle, right? If the value is larger than the middle, yeah, it depends, right? So we have the middle is here, and then the value, if it's smaller than the middle, then we compare to the front and compare to here, right? If it's smaller than the middle but bigger than this, then we know it's going to be in this. If it's also smaller than this, or smaller than this and smaller than this, then it's going to be in this part, right? So each time when you find a middle, you have to consider, right? And of course, another thing we have to consider is if I'm bigger than this, it could be in here, but if I'm bigger than this but smaller than this, then it has to be in this part, right? So basically, if it's landing this part or landing this part, then we know. Otherwise, it's going to be in the middle. So it doesn't matter. We have a middle, right? We have a middle, and we need to first compare the middle value to the left and to the right. If the middle value is larger than the left, then you know it's on this half. If it's smaller than the right, then it must be in this half. And then you compare the target with the middle, if it's on this half or if it's on the... Okay, I think we can analyze this. need this. Okie dokie. We're gonna delete this whole thing. All right. So I'm gonna search. Int low equal to 0. Int high equal to nums.length -1. Hold on. Dot length -1. Okay. While low smaller than high, int mid equal to low divided by high. That's integer division, right? I'm not sure. Oh, my bad. What are you doing? Low plus high divided by 2. Okay. Now, what we need to do is check, because it could be on this side, right? So if this one is larger than the left, if nums mid is larger than nums 0, right? If that's the case, then we know this one is in this half. Then we compare the target. We say if target, we say if yeah, we can try to get closer. Oh, the edge. Oof. Because we all say low is the plus equal 1. Okay. Hold on. If nums middle is larger than nums 0, we know the middle is in here, which is fine. Then then we compare the middle to the target, right? When I say if nums middle, or let's show easier, we say if target, if it's smaller or equal to nums middle. All right, target is smaller or equal to nums middle, and we know nums middle is larger than this. Target is small. Target is smaller than nums middle. So it could be on this side or on this side. You know what? Let me change this. If target is larger than, let's do larger than. If target is larger than, right? Then we say, you know what? Let's do this. If nums mid is equal to target, right? Then we return what? Index, return mid. Otherwise, then we're gonna do if target is larger than nums mid, then in this case we'll say low equals mid plus 1, right? Because it's gonna be on this side, so we have to do low equals mid plus 1. Else, so if the target is smaller than, then it depends, right? Or we can say if target larger than, or I see, this is not the best. So if target is small equal to nums mid and target is larger or equal to num0, right? If target is in between this, then high, we move high down. High equal to mid minus 1. Well, high is equal to mid because we say equal to. So high will equal to mid. Else, so it's outside, right? So target is larger than this. Yeah. Then no matter what, then we say low equals to mid plus 1. Right? That's if num's mid is larger than this. Else, num's mid is smaller than this, which means num's mid is not on this side. So we say if target is smaller or equal to nums, I don't think I have 9 minus 1, nums dot length minus 1. Alright, if it's smaller or equal to this, or no, and target is larger or equal to nums mid. So we are in this half. Then we say low equal to mid. I want to do low equal to mid plus 1. If you say low equal to mid plus 1, then this has to be larger than, right? And you say otherwise, high equal to mid. And we'll keep going until at the end, or 2 minus 1. All right, is this one correct? I don't know. First shot. Oh, I think we have an infinite loop. Okay, so maybe we should do this. Looks good. Maybe what we can do is we don't check it here, okay? Because we false low equals mid plus 1. So once we find it and then we come out, let's target is smaller equal to, and target is larger equal to. Yeah, it's a little bit, you know what, I don't like it. I think what I would do is when you force mid minus 1 as well. So if I do this, and if it's smaller than, or is larger than this, high equal to mid minus 1. Because I already handled this equal case, so this I don't need anymore, right? And here is the same, I handled. So it's larger, I handled the equal case, so if it's larger, otherwise we say this is minus 1. Yep. Give it a shot. CPP the last time. Oh my goodness. Edge case. Holy crap. 3, 1, and a 1. Ugh. So mid we start 1. Right? We start low high. Okay? Low smaller high, 0, 1 divided by 2 is 0. Divided by 2 is 0. And mid 0 no. And 0 is larger than, here is the case, is larger than this no, so, but it has to be smaller. I mean, this should be larger or equal to. Yeah, because it will always bias towards this, right? So always say larger equal to. Mid, because it will always be here, right? If it's larger equal to, then we stay on this side. And then we'll say target is 1. 1 is smaller than this, yes. And 1 larger, no. Then it's on the other side. So low equals mid minus 1. So I think this shall be right. This shall be larger or equal to. This should be larger or equal to. Alright, try this one. Yeah. Should be larger or equal to. A more complex binary search. All right, let's see. Now we can go for Java. Search, binary search. This is binary search. If nums mid is larger than nums n minus 1. Yes, so, okay, that's the simple case. Oh, find the index of the pivot. It's trying to find a pivot first. Yeah, if mid is larger than the right, then it must be, if mid is larger than nums n minus 1, then it must be on the left half. No, it must be on the, wait, hold on. Nums mid larger than the end, right? So it's on the left side. But why do the left equals mid plus 1? I'm not quite sure. I'm not quite sure. Left smaller equal to right, right? If nums mid is larger than nums n minus 1. This is shift. One binary search. Yeah, I think that's pretty similar to what I have. Not exactly the same, but it's pretty similar. Oh yeah, I can do the left here. Oh yeah, I can do a right. Yes. Yes. It can be a left. Yeah, all the 0 can be left. Yes. Okay, what I don't understand is this thing. Right, this part I don't understand. Find the index of the pivot element, which is the smallest element. So if nums mid in the midpoint, if it's larger than, so the midpoint is on the right. Oh, I want to find the smallest. So this is on the left hand side. So left. Oh, okay, that makes sense now. This makes sense now. Update. During binary search, we can compare nums mid. We can use nums low and nums high for the left and right boundary instead of nums 0 and nums dot length -1. So here we can say, right, because I have left, low, and a high, right? So it's large or equal to low, then we will say it's the left half, right? Then we do this and target large to low, and this we can just say high. Yep. What did I do with the CPP? Oh, yeah. Okay, what surprises me, this CPP is 4 milliseconds, but this Java is 0 millisecond, 195. Yeah. All right, we need to copy and paste this. 08. Okay. Now, oh, why did you turn it off? No. We're done with this. We need to do 2.7. Wait, did I not turn on 2.7? Oh, no, I haven't. No, I haven't. That's okay. Yeah, all right, so we have to figure out what goes wrong here. I honestly have no clue. I thought it was right, but there's something we can improve. For example, we can have another function here to call it public boolean value. Not boolean. I want to do. What do you want to do? Length int. Match the length. Okay, match the length. Match the length will do a string. String s, right? String s, because I want to debug this thing, right? I want to debug this thing, so I have string s index int index. So I have string index and try node, right? So basically we are doing this thing. So we say root is this, I is this, smooth. Oh, we have to return also the index as well. Yeah, I don't think this is a wise decision. I think we can. Hold on, I need to redo this one for sure. String ss equal to new string this LeetCode, right? And then just say hello world. Is it all right? Array initialization not allowed. Okay, so it has to be arrays. No, I think I can do list dot off. No? Huh? Wait, how do I initialize the array? New string list of. No, this should be right. What is this problem? Oh. The new string doesn't have this. There we go. Dictionaries. We're gonna say, oof. Because that's gonna be array list. Array list of string this. Dictionaries. Dicts equal to new. Array list. List dot off something something new string this something and new string this something, right? That makes sense. And I want them to come here, so I have clear indication of what they are. Ugly. Okay, this is gonna be LeetCode. This is gonna be hello world. All right, solution for I equals answer 9. Wait, what's this from? Okay. Wow. That's strings.add. Now I don't need this one. Seriously, that's how you do it? Ha. Okay, for starter, I will just do num tests. Okay, go to 1. I want the current. I'm just going to do 1 for debugging purposes. So solution dot main extra char. Right, main extra char. We're going to do ss dot get. No. ss dot now SSI and dicts I. That's not right. Dicts.get I. And it's not supposed to be boolean. It's supposed to be an int. Oh, an answer. Dude, answers. Answers is gonna be int goes new int 1 and 3. Okay, we can run this. Yeah. Okay. Now we can try to see what goes wrong? Where do we put the maybe I can do a memo, just kind of see how things are. How do you do memo? This.dp. We can do this. Int res equal to this, and now return res. But before we're doing that, you know what? No, we need to learn to use. Okay, so what we're gonna do is we put it here. Then we will run debug. Okay. Is resume, stop, step in. Okay, so where am I? S is LeetCode, dictionary is this, root is try, CT, L, because I have L, yes. Oh my god, this is good. Wait, hold a second. C and L. Key equal to C again? Oh. What is no? Hold on. Key is C. Value is another dict with an O, and a value shall be another dict with D, right? And then D value shall be another dict. The dict shall have an E. E, the key is E. Value shall be an encode. Yes, I think this one's correct. Let's try this. Value should be E. Value is ELEE. Right, value is a dict T, leet. And this one, value T. Oh, T. Oh, I did that wrong. This actually this shouldn't be no, because I do T, right? That key is T. The value, we shall have the word. It shouldn't be null, right? Right here. Oh. Yeah, L, the current value is null, right? We go inside. Its value, that's key. Next, the dict E value is this, right? And the value is, oh, this is still confusing. So E, we have a, you have a dictionary key is E. The value is this. Key. So the value, yes, we should always go value. So dict, we have E, right? And then we go value. Then dict is T. You can see the dict is T. We have value. The key is T, right? Then the value, this value, the word should not be null. This value should be the actual thing. But instead, I just keep going on. O, D, and then last one is E. I'm going to say this value gave you LeetCode. So what happens is we build the, okay, I can cancel this. We build the try wrong. Wow, the debugging is quite useful. Okay, so we build the try wrong because I only handle it at the end. But hold a second. I did this every single word, right? It shouldn't. It should not. For each word in dictionary, right? I have LEET and no.word equals word. And then, oh, I know. I directly put, no. If, oh crap, if node.dict contains key, letter, then node equal, if not contains, there we go, that's the key. Oh yeah, I did this one wrong. Right? If it doesn't contain the key, we put it, otherwise we just go to this. If we do this disconnect, hold on, what's this? View breakpoints, mute breakpoint. I mean, I quit the rerun main. Oh, I was in the debug mode. Now I pass, right? And now we can say this is, let's say, answers.length. Yep, now we pass both. Okay, let's put it here. Yeah, have a slight issue around the build of the try. So now we can try. Let's see if it passes. Ugh. Okay. Now what do you think is the problem? If the try is correct, right? Oh gosh. Yeah, I have faith now that the try should be correct, because each one is only if it doesn't contain, then I create a new one. If it contains, I just, keep getting, and at the end I set this. Okay, so now the memo, the DP, I was trying to say, given the index, right, I want to find from this towards the end, what's the minimum number, right, what's the minimum number, and I say, if index get out, then it's a 0, because the minimum moving is 0, that's correct. Otherwise, I take s index as the extra character, which is fine, right? Extra character. And then, because I take the current as extra character, I have 1 extra character. Then I do this +1. That makes sense to me. Otherwise, we try to fit starting from s towards the end, right? Then I say this, the letter is the current character, and we say if node.dict contains the current, right? If it contains, then no equal to this, I++. if node.word is not null, that means we fit the current. Ooh, but it should, I don't know. It should, right? Are you saying for each position, I shall try included or not included? That doesn't make any sense. So now this every time I try it doesn't include. So the next one I also try, the current one doesn't include, and or we try to include everything. It doesn't include or include everything. I don't know. Yeah. Yeah, this doesn't include, so basically it's 2. And we try to find the max. Huh. You know what? Maybe we should change this instead of doing this. Hold on. Do they have a? Does Java has math maximum integer? Integer.math value. So maybe I can do it here. I can say memo.put index integer.max value, and then we say for, I don't know, yeah, that doesn't make any sense. That one might as well I just use, if you want to do it that way, if you want to go 1 by 1. Nah, that doesn't make any sense to me. Yeah, because we try to find I might include more. Ooh. Hold a second. I think I know the problem. So here, what I'm saying is I would match the maximum, right? But what if I shall match only one word? Right? That's what we need. I should only match one word. But what if you can match one word, or match 2 words, or match 3 words? So for each of them, that's a different scenario, right? For each of them, that's a different scenario. So what I'm saying now is, how about, well, this is smaller than length, right? For this, if it contains letter, node equals node dot get, then we need to check, right? We need to check if node.word is not equal to null. That's one scenario we have to consider. All right, we can say memo.put index math.min dp I memo as root memo.get index. So every time we hit a word, we try it. Right? Once we try it, we keep going until it comes out. And just to be sure that each time we do this, right? Each time we do this, we will try. So if we have certain time when this does not contain, right? If it does not contain anymore, and then it comes out, I have to try it one more time, right? I have to try it one more time. So I have to try this. Okay, now let's see if this is correct. I do not want to test on my stuff. Let's just copy paste here. So we add a little bit more. So does this one pass? Yep. Looks promising. There we go. Ooh. The first complex stuff done in Java in a very, very long time. Oh, no, that's Python. Okay, so build a try. Right, build a try and go through S one by one. Nah, I don't like to build a try out of dictionary. For each use a DP. Use DP index to represent, to find the minimum extra characters in S index to the end. Okay. The tricky part is that as we go through S index, we need to run DP each time a word is found. Each time a word is found. Also for each S index, we have to consider a separate operation where S index is not considered. All right, runtime. Well, what is the runtime for this? Well, we have in total index. Well, I take total number. So I take total number of word. We call it M. All right, that's to build the try. And then for this, we call DP. So we have N state, but for each state, we go through the whole thing. So I'll say squared, where M is the total number of letters in dictionary. All right. Top-down DP with substring method. Is that a try? Is a so-called substring method a try? Oh Lord, look at this. So simple. Time complexity, ON triple. Oh, did I got it wrong? Bottom up. Let's try. Yeah, this is try. Yep, that's right. ON squared. Average length. Yep, we got it right. I did do a try note. A map. Is word. Or build. Ah, nice. Yeah, you should do this. You should build try. You should do that. You should do this build try. I did not call a function. I just build a try directly. And then I set up a memo. Okay, I give it to you. This is actually a better way to do memo. I agree. New integer. Integer this. Okay. Try not to put on the outside. Don't put it on the inside. and dp 0, n is the length, s. Where's the mem? Oh, memo is shared. Oh, memo is shared. The root is shared as well. And the dp star equal to n. That's correct. If this star is not equal to null, return. Okay. And yes, because the root is shared. So this is yes. What the hell is this? End is start. Oh, that's the start. If not, we're gonna break. If it is, I see. Yeah, this is much easier, huh? Oh yeah, you don't even need to know. Why do you need to get the word? You don't need to get the word. Okay, so whew. What do we need? I need to copy and paste this. Consider this as solution 1. So that's solution 1. Okay. Now we're gonna do solution 2. I will use this one. Okay, so try node for 1. This has to be hash map, but this is a boolean. Yeah, a boolean value will work. Boolean is word. Okay, then we'll do better here. Inspired by the official solution to make the implementation better. Basically, write better Java code. The runtime is the same. Okay, so we can do this integer dp. Actually, why you return this integer, right? I mean, you can just do int, and this can be int. You don't need hash map, because I can do this hash map. Oh, it's not giving a hash map. No. It's what's a memo? Memo is int. Memo, right? That's what memo is. And try node root. So in this way, I don't have to pass this, nor do I need to pass this. And then I have the dp. Then you should also have a create. So we say try node create try. We need to pass the string dictionary. Okay, and this we will do this. Put it here. So root equal to this. String there. That's not word, is word will be true. Because default value for boolean, we can actually say default value is false. Okay, so that, then we'll return root. Okay, so now we can say root equal to, I can directly call, you don't have to say this. I did not know that. You can directly call it. And then we can say memo equal to new int index, right? So it'll be s.length. So this is not necessary. Now we're gonna return 0. We don't have to pass memo because it's global. Not global, just overall to the whole thing. So we just pass a 0, s, what else do we need? That's it, 0 and s. Now we're gonna handle this dp, so it's just this and this, right? So we say if memo, because it's an array, we can say if this is not equal to null. Is that right? Int and null. What did you use here? Oh, integer. And you can do new integer. I see, you use integer. You use integer because integer, that's a reference type. So you can check for null. But in this, it's an int. So if you want to check, I think the default value is 0. But 0 is a valid, so you cannot use. Oh, makes sense. I have to be integer, right? Then this one is right. But here, this is not right because that's not int, that's integer. Gotcha. So we can check this and, well, we can just return, right? And if s index is equal to this, then we can just return. That's fine. Okay, so option 1, we can say index equal to, can I say that? Create dp solution. That's fine, doesn't matter. Right, index, I guess, but memo is the big integer. And here, this, I guess you can, I don't know, you can do that? I guess you can, right? Hold on. I guess you can. Where's the dp? Bottom up, top down. Yeah, you can, because this is a primitive, but you can assign it to a big integer. Hold on. So do I need to convert int to integer, or is it not necessary? Int to integer, the value of, interesting. Do I need to convert? I mean, if you want to be correct, right? Yeah, I want to be int answer res, right, equal to this. And option 2 is we'll go through the whole thing. Yeah, I think I should actually say int I equal to index I smaller than s.length I plus plus, right? And we get a string, not string, we get a character out. They didn't do the character. They did character. char at. Oh, character. Holy crap. You can use character. I did not know that. Oh, character. So I can simply say, hold on, so I can simply say if node.dict dot contains key s.char at I. Right, I can do that. If that's the case, then node will equal to node.dict.get s.char at I. Right? Once we handle this, then we say if node.isWord is true, then answer res equal to minimum res, and dp, we call dp again, is math.min, my bad, I have to call math.min. Yeah, and now we go through all this. And else we're gonna break. Yeah, we should put this one inside. If it's contained inside, I do this. Right, if it's contained inside, I do this. I also break. And at the end, we say memo index will equal to res return res. So that's the DP. Now I will create, then now I just need to return. So I don't need to call this .dp. I guess I can just call dp because it's within the same. And yeah, technically this also shall be int, right? Okay, let's run this. Ugh. Oh, yeah, that's right. So, because I changed it. So this contains this. Then I'll put this and I'll get this. Index out of bound. Where? Index out of bound. Oh, that's correct. My bad. We have to check this first, then do this. Ugh. Shoot. What happened? This should still be right. We didn't change anything here, right? So it's with the DP. Something's wrong with the DP. This is right. I just do +1. Should be fine. Option 2, we'll try to start. So we start from index. And we say if it contains I, right? If it contains I, node will go to the next one. If this is word, because every time it's a word, I set it to true. If it's a word, then I will say dp I plus 1 because I haven't plus plus yet. There we go. Okay. We'll try this thing. Create. What should I say? It's fun. Yeah, you just need practice. We know that we're not the most fluent in Java. Oh, I have it here. We're not the most fluent in Java. So what we need to do is just be more fluent in Java by writing more Java. This one's actually faster. Okay. I think that's it. I do not intend to do one more. These things are quite draining your brain, you know. All right, that will be it. I will see you guys tomorrow. Adios.